today's tutorial on Best Science Brain YouTube channel. We are still treating another aspect of organic chemistry. Today we're looking at nomenclature of aliphatic compounds. So if this video is new to you or you're seeing the video for the very first time, kindly move up to the channel's name, Best Science Brain. On the channel's name, you're going to see the subscription button or a tiny bell, subscription. Tap on the subscription only once and get subscribed to the channel to be seeing our videos from time to time. So today we're going to focus on the nomenclature of aliphatic compounds. Aliphatic compounds in chemistry, organic chemistry, are compounds that involved, we can call them the chain compounds. Either the straight chain, what they come out us are in a straight line, or they could be branch chains, where you have a straight chain linked to a branch chain. Or under aliphatic, you can also have cyclic compounds. Cyclic compound, they are also classified as aliphatic compounds in chemistry. So our focus today is not to draw the structure of this compound, but how to name aliphatic compounds, straight chain, branch chain compounds, and cyclic compounds. So we're going to look at the general rules that are specified for naming aliphatic compound according to Aliphatic nomenclature. We'll take the first rule. We'll go to the rules one by one, the important ones for now. The first rule says, take the longest continuous carbon chain as the parent or root chain. Take the longest continuous carbon chain as the parent or root chain. The parent chain could be a straight chain or a branch chain. For instance, if I have the chain containing 6 carbon atoms, there is no branching here. This compound will have the root name hexane because it's an alkane compound, it's saturated. It will have the root name hexane because of the 6 carbon atoms on a straight chain. Let's say we have this situation of branch chain. Here, we first of all find the longest carbon chain. So have a straight chain here and we'll have a branch in there. So you count it. How do you count? From here, number 1, number 2, number 3, number 4, number 5, number 6 carbon. So you are obtaining 6. Then remove the numbers again. If you count from this end, I will still get 1, 2, 3, 4, 5, 6. 6. Then let's count the branch. Count the branch chain. I can move from here down. That is number 1 carbon, number 2, number 3, number 4. I'll obtain another number 4 carbon atoms. Let us remove this. Possible ways of counting. I'll start from this end to get 4. Then let me move from this end and cut down there. Number 1, number 2, number 3, number 4, number 5. So from here, 1, 2, 3, 4, 5 carbon atoms. So this is 5 here now. So the possible ways of counting, if you count straight, you have 6. atoms. Let's start at the beginning. If you count straight, you have 6, either this way or there are 6 carbon atoms. Then you count the branch. Here you have 1, 2, 3, 4 carbon atoms. You start from just the other end and count the branch. You have 1, 2, 3, 4, 5. Then out of these numbers, 6, 4, 5, the highest is 6. We go by 6. So this compound we end with the root name Zen also. So let's look at another example of how to identify the longest continuous carbon skeleton. Let's have 1, 2, 3, 4, 5, 6. You have carbon, 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 carbon. Okay, let's see this structure. So how do we identify the longest chain here? As we said before, the longest chain must not be a straight chain. For this one now, the straight chain gives you 1, 2, 3, 4, 5, 6. Whether you count like this or you count like this, 1, 2, 3, 4, 5, 6. So I've gotten 6 as a straight chain. When I consider the branch you can move like this, down, one-way traffic. 1, 2, 3, 4, 5, 6, 7. We're getting 7. We'll move it again. Which other way can we count the branch? We start from the other end and move down. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This gives us 8. Longest chain now is 8 carbon atoms. So this compound will end with the root name octane. Octane. The end with the root name octane because of the single bonds present in it. So, identify the longest chain is the most important thing you have to do when you want to name an aliphatic organic compound. Identify all substituents, that is groups appending from the parent chain. What are the substituents? The substituents we have in aliphatic compounds can include the halo groups. The halo groups, like our fluorine as something is called fluoro. Our chlorine is called chloro. We have bromine is pronounced bromo. We have iodine is pronounced iodo. We have the alkyl groups like alkyl, this is called methyl. This is called ethyl. Propyl, and so on. These are called the substituents present. We call them, or term them secondary substituents. Then the primary substituents, we'll take these ones as the major functional groups. The functional groups, which could be the carbon-carbon double bond. Double bond for the alkenes, the triple bond for the alkynes when they are present, the hydroxyl group for the alkanols, that is, they put it this way, OH, hydroxyl. Then the carboxyl group for the alkanoic acids, and so on. So these ones are the primary or the principal substituents, while these ones are secondary substituents. So when you have an organic compound, the second rule says you should identify the groups that are on the parent chain. Let me give you an example. We could have this compound. Okay. or have this kind of compound. So the first thing we have to do here is identify the longest chain. As we did in the first rule, the longest carbon chain, of course, is 1, 2, 3, 4, 5, 6. 6. This carbon is also a branch. 1, 2, 3, 4, 5. 5 greater than 6, so this cannot be the longest if I move this way. 1, 2, 3, 4 is not. The longest chain is thread chain, which gives us 6 carbon. Like hexane, this compound will end with the name hexane, but that is not the full name. Then the subtrains, what subtrains are appended on this parent chain? Identify all the subtrains appending from the parent chain. Subtrains are chloro and methyl. Chloro and methyl. So these are the subtrains here. Then when you want to name the compounds, this compound, you have to put into consideration the subtrains that are present when you're naming the compound fully. Then if I have these, for instance, what are the subtrains that are present in this compound? Are the question we want to ask ourselves now. H here, we also have Cl. The subtrains here, you can see them. This is chloro, this is bromo. These two are the secondary subtrains. But the primary subtrain with the first triangle is the double bond. This is the primary subtrain, while these two are secondary substituents. So we're going to see how to name these kind of compounds as we go to the other rules. So rule number 3 says number the carbon atoms of the parent chain from the end that gives the substituents the lowest numbers. Let's look at an example here. For instance, we have chlorine here. There is only one substituent, chlorine. Every other atom here says hydrogen. If we had hydrogen here, it would have been a full hydrocarbon. So this substituent has got to place for hydrogen. There is only one. Then we have only a straight chain because there's no branching to any other carbon. We have only a straight chain. The longest chain here is 1, 2, 3, 4, 5. It's a pentane compound. Now, this rule says number the carbon atoms of the parent chain from the end that give the substituents. Of course, there's only one substituent here, the lowest number. There are two ends here. They call this end A, call this end B. So we're going to number from either A or from either B for the end that give this carbon atom the smallest number. If I start with this end, this will be 1, 2, 3, and 4. But for this end, I will have 1, 2. So 1, 2 is preferred than using this end 1, 2, 3, 4. So 2 is lower. So this is the numbering. To name this compound now, this chlorine is on number 2. I'll now write 2 hyphen chloro, not chlorine. 2 hyphen chloro. That is the position, the locant. The position of the substance is number 2. 2 chloro. Then the name of the compound, the full compound is 1, 2, 3, 4, 5. And it contains single bond, that is an alkane compound. 2 chloropentane. So this is a haloalkane. 2 chloropentane. You make sure that if you are naming, after a number, you put a hyphen. Then chloro, the names, the chloro and pentane must be joined together, no spacing between them. If a particular substituent occurs more than once, the location of each point on which the substituent occurs is given, full stop. In addition, number of times the substituent occurs is indicated by a prefix, bracket bracket opens, you have di, tri, tetra, and so on. So let's explain this through now. Let's say we have this organic structure. We have a particular substituent. The substituent here is chlorine, occurring more than once. The same kind of substituent occurring more than once. How do we name this compound? Rule number 1 says we should find the longest carbon chain, continuous chain. And of course, all the carbon atoms are in a straight line here. There's no branching to carbon. This is not carbon. So 1, 2, 3, 4. So, and single bonds ends with is alkane compound. So now, on alkane derivative, 1, 2, 3, 4. Now you have substituents here. Numbering, which should be from the end that will give us a closer, an A or B, a closer proximity to the carbon atom. So then the substituent. So if I start from here, this will be number 1, number 2, number 3, number 4. If I start from this end, number 1, number 2, number 3. So 2 and 3, they're the same, and that's similar kind. So how would I name this compound? I have chlorine, and I also have chlorine. So I'll take the numbers first. I'll say the locals, 2 and 3. And I'll say 2, 3. Comma separates numbers. While hyphen separates numbers and words. 2, 3, 2, 3, and then hyphen. The substituents are the same kind, and when they are 2 or the same kind, use the word di. And I'll say di. The name of the substituent is chloro. Dichloro. The longest chain is 4 with a single bond, that is butane. You see that? The numbers are separated by comma, then the numbers separated by from words by hyphen, then every other thing should be joined together. So that will be the name of the compound, 2,3-dichlorobutane. So when we have more than one substituent of the same kind, you apply these multiplying prefixes. 2 when they are two of the same kind. 3 when they are two of the same kind. Another example is this one. You have this compound 1, 2, 3, 4, 5. Hydrogen, hydrogen, hydrogen. Bromine here, bromine there. Hydrogen, or bromine here, bromine there. Hydrogen, hydrogen, hydrogen. So how do I name this compound? First of all, I have to find the longest continuous chain. The longest carbon skeleton is 5. 1, 2, 3, 4, 5. There's no branching. So all the other atoms around here are not carbon. So the longest chain is 5. Single bond makes it to be an alkane derivative, that is pentane. Then we number, these substituents are here. You can see this, see this, see this. They're the same kind. We number from the end that provide the least possible number to the carbon of the substituent groups. If I start to have this end A, we have this end B. If I start from this end, I'm going to have 1, 2, and 3. From this end, I'm going to have 1, 2, 3, and 4. So 2 and 3 is smaller than 3 and 4. So we choose the lower values. To name the compound, this is now called 2, 2. Why would I use 2, 2? Each substituent takes the number. This first 2 for this, second 2 for the other one. Then for this one, I'll now say 3, 3, because there are 2 of them on number 3. Then hyphen. How many of them are the same kind? There are 4. I use the prefix tetra. Tetra. The name of the substituent is called bromo. Then the longest chain, as I said, is 5. Bromopentane. You see, numbers are separated by commas. Then from words by hyphen. Every other thing joined together, no spacing. That says if there are 2 or more different substituents, they are listed in alphabetical order using the base name. Ignore prefixes. processes. Let's look at this example. Let's explain with this example. Let's say you have substances, bromine, chlorine. They are different kinds now. Bromine and chlorine. So what do I do? How would I name this compound? First of all, I identify the longest carbon skeleton, carbon chain. The longest is a straight chain, but there's no branch chain there. 1, 2, 3, 4, 5. These ones are not carbon. So 5 straight chain, that is alkane derivative, pentane. Then the substances are these, and that they are not the same kind. So how will I name the compound now? To name the compound, I have to number. First of all, the rule number 2, number from the end that gives you a smaller number to the carbon of the substance. So from this end, we have 1, 2, 3, 4, 5. And from this end, we have 1, 2, 3, and 4. So 2 and 3 is smaller than 3 and 4. We choose this end, 2, 3. Now to name this compound, we have bromine, we have chlorine. So when you want to name, numbering is not done by alphabetical order. Numbering is done based on proximity from the end. But naming now will be by alphabetical order. This is called bromo. This is called chloro. As you can see, B comes first before C. In naming, you now have 2 hyphen bromo. You see, because this one comes first in English alphabetical order. Then this one is number 3. Now say 3 hyphen again, 3 chloro, not comma. Because the numbers are not together for you to put comma. Hyphen, hyphen. 2 bromo, 3 chloro. The longest chain is 5, pentane. So that's the name of the compound. 2 chloro, 2 bromo, 3 chloro, pentane. So that is the Aliphatic nomenclature of that compound. The question is this: what if we replace this one with chlorine and this one with bromine? Will the name remain the same? Let's see. Okay. We'll change their position and see whether the name will be the same. When we change the position, then in numbering, now, let's go ahead. Start from the beginning again. The longest chain is 1, 2, 3, 4, 5. 5 carbon atoms here. So now 5, we're getting pentane derivative. Then in numbering, will I start from this end to number because bromine comes first in the alphabet? No, I said that numbering will follow proximity from the end. So this is 1, 2, 3. No, rather this end 1, 2, because this end is closer compared to this end. Not minding whether this one is started with a lower letter or a bigger letter. So it's 1, 2, 3. So when you are naming, when you are naming is when you apply the order. So in naming, this is now called, you start with B, bromo first. But in numbering, you don't use the order to number, please. So this is now called 3 bromo. That is it. Because B should be named before C. Then 2 chloro. Pentane. You see that the name has changed. 3 bromo and 2 chloro pentane. Okay? Then, is there any case whereby you will not be able to, okay, let's look at this example, to dodge alphabetical order. Let's see this. You have bromine here, you have chlorine there. So you can see this example now. To name this compound, what do we do? The longest chain remains 4. It's a potent derivative. Remains 4. Now to name the compound, what do we do? If I start from this end to end to number 1, 2, 3, this end will still give me 1, 2, 3, 2, 3, also 2, 3. What do we do? There are nothing we can do here. The only thing we can use to distinguish the two of them, it will now be only alphabetical order, because if you start from this end, the locant is 2. From this end, the locant is also 2. So the only thing we can do is use alphabetical order to separate them. So you now number by alphabetical order since you cannot dodge it. So you have 1, 2, 3. This is now called 2 bromo, 3 chloro. occurs butane. Alright. So we're going to take examples now and run through this nomenclature. Examples on the board of how to name aliphatic compounds. Then look at this one. Name this compound. We have to first of all identify the longest chain. Also, as a beginner, you can open the structure. This is carbon with 3 hydrogen. You can open it up on your own. Then this is carbon with 1 hydrogen and a methyl group up. Carbon again, the third carbon with hydrogen and a methyl group down. Carbon with 2 hydrogen atoms and then a methyl group at the extreme. So if you are good at it, you can name it from here. If you're a beginner, I suggest that you open the structure to help yourself. Now, we are going to find the longest chain that the root goes. You find the longest continuous chain. Continuous chain, as you say, can be a straight chain or a branch chain. And you can see that there are some common atoms on the branches. So let's first of all count the straight chain. 1, 2, 3, 4, 5. We have 5 there. Then the branch chain, I can count like this. 1, 2, 3. 3 less than 5. So I'll discard that. 1, 2, 3, 4. 1, 2, 3, 4. 4 less than 5. I discard that. From this end, 1, 2, 3, 4. 4 is less than 5. I discard that 4. For this end again, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Remind you, I've already obtained 5 in a straight chain. So one of the branches is also giving me 5. So in this situation now, I will use the straight chain as the root name because it's equal to that of this branch chain. Had it been that the branch chain is higher number than the straight chain, the branch chain would have been the root name anyway. In this case, I'm using this 5. So having done that, this is the compound will go with the name 5, pentane with the hydrocarbon. Now, having done that, we now look at the look and the position of the substance. Now, this two now will no longer be part of the straight chain. Now we call them the substituents because they are no longer part of the straight chain. Sorry, they are no longer part of the parent chain. So the number either from MA is the parent chain or MB. This will give me 1, 2, 3, and 4. 3 and 4. Why does it give me 1, 2, and 3? Prefer the lower numbering. We'll have 1, 2, and then 3, which is better than using 3 and 4. Then, to name it, these two groups are the same. And I call it 2, 3. 2, 3, the numbers first, since they are similar, the numbers will go first because they are similar groups. Then hyphen, the prefix die, because showing there are 2. So 2, 3 die. The name of this substituent is methyl pentane. That's the name of the compound. 2, 3 dimethyl pentane. Now going to the one number 2 under, we now have this compound. I can open it and see count it this way. Count it this way. Then count the stretching first. 1, 2, 3, 4, 5. 5 carbon. Let me count the branches. 1, 2, 3. No, it's less than 5. 1, 2, 3, 4, 5. Or already obtained 5 before. 1, 2, 3. Since the stretching gives us 5, which is equal to one of the branches, we use the stretching and ignore the branching. So whenever the branching is given the higher number. So we have this. To name this compound, consider both ends. This is 1, 2. For this up there, and this is also 1, 2. And the substituents are the same. So whether this end, 1, 2, or from this end, it gives the same numbering. So you can start from any end you want. So this is number 1, number 2, number 3, carbon number 4, number 5. Should I start on this side? It's going to be number 1, number 2, number 3, number 4, number 5. The same thing because this is 2, 4. Here 2, 4. They're the same kind. So now I have the name 2. You take the numbers first. 2, 4, showing the position of the similar substance. 2, 4. Then dimethyl. Di showing plural, there are 2. And then 5 is a pentane. The numbers separated by comma. Then separate the number from the words by hyphen and join every other thing together. So go to example number 3 on the board here. This one is a Herculean task. Go to solve it. To solve it, first we'll find the longest continuous chain. How do you count it? Let me get a straight chain first. 1, 2, 3, 4. Number 4, carbon 4. Then the branch chain, the many branches here. If I start from this end, 1, 2, 3, 4. 4 again. I'll count it like this. Then 1, let me count again. 1, 2, 3, 4, 5, 6. Repeat myself. 1, 2, 3, 4, 5, 6. Obtain 6. 6 is greater now. We come back again from this end. 1, 2, 3, 4, 5. Obtain 5. So I strike off 4 and 5. This is higher. 1, 2, 3, 4, 5. 1, 2, 3, 4. Lower. Which other end is remaining now? Let's move up. 1, 2, 3, 4, 5, 6. Look at the 6. 1, 2, 3, 4, 5, 6, 7. You can see that. You can see move like this and like that. 1, 2, 3, 4, 5, 6. That's 7 the longest chain. The compound we end with, if you have a carbon, we end with heptane. It's our 10, 7. 1, 2, let me make it right. Draw it in the right manner. Okay. It's carbon. So this is the parent chain root name. So now we're going to number the parent chain. Here this is the parent chain. This is the carbon of the parent chain. 1, 2, 3. Mark them asterisks. The carbons on the parent chain mark asterisks. So don't make any mistake about it. Then, having done that, we now look at this carbon that is not part of the straight chain is circled. It becomes a substituent. This carbon that is not part of the straight chain becomes a substituent or a substituent group. Then check this side. This carbon that is not part of the straight chain becomes also a substituent because it's not part of the 7 carbons. It's counted as straight chain. Then we now number the straight chain. We have here number 1, number 2, number 3. To get this, so there is number 3. Then number 4. Let me start from this end. Number 1, number 2, number 3. So why I said this is 1, 2, 3. This is also 1, 2, 3. The substance are the same kind. So if I start from this place, 3. If I start from this place, this will be on number 3. So any end, can start from this end to number, can start from this end to number. If this place was giving us 3, and this place is giving us 4, then you have to start from this end. So any end can work here. Now I have number 1, number 2 carbon, number 3, number 4, number 5 carbon, number 6, number 7. Only number the carbon atoms that form the parent chain. So now having done that, this methyl group is on number 3. This other methyl group is on number 4 carbon. This one is on number, where is it? This one is on number 5 carbon. So when I take the numbers are number 3, that is here, 3. This one is on number 4 carbon of the straight chain, number 4, or the parent chain, sorry. And this one is on number 5 carbon of the parent chain, number 5. 3, 4, 5. And so there are 3 substituents. Then that same can now say hyphen trimethyl. Trimethyl, indicating 3 of them. And the longest chain is 7, as I indicated before. Pentane. So the compound is 3, 4, 5 trimethyl pentane. So that's the name of the compound. It's the biggest one, we'll have to solve it. So go to number 4 example. Number 4 example is also somehow is a hydrocarbon. We have to find the longest chain also. The longest chain, let's first of all count the thread chain. This is 1, 2, 3, 4, 5. You will take 5 on the thread chain. Then let's count the branch. 1, 2, 3, 4, 5. The same 5. So like this. 1, 2, 3, 4, 5. The branch on the other side. 1, 2, 3, 4, 5, 6. We'll take 6. So strike off 5. Let's repeat again. 1, 2, 3, 4, 5, 6. Then branch can also be counted here. 1, 2, 3, 4, 5, 6. Same 6. When you move like this, 1, 2, 3, 4, 5, 6. Like this, 1, 2, 3, 4, 5, 6. So let's count the branch from here. 1, 2, 3, 4, 5, 6. So you see that the longest chain is 6 in all ramifications. I'm having 6. So take one of the 6. 1, 2, 3, 4, 5, 6. So let me take from here as my longest chain. 1, 2, 3, 4, 5, 6. Longest chain. So the carbon that make the parent chain, I'll mark them as sterics. You can see them marked as sterics. While this remaining group, carbon, will now become the substituents. So because they're not part of this parent chain. Now to number this parent chain, this is 1, 2, 3, number 3. So the substituent will be on number 3. If I start from this end. From this end, 1, 2, 3, 4. So which end is preferable here? So this end is preferable. 1, 2, 3 for this carbon, where the substituents are lying. But if I start with this, they're going to have 1, 2, 3, 4. So I prefer to start with this end. That give me a smaller number. 1, 2, 3, then 4, 5, 6. Then what do we call these substituents? This substituent is not methyl. This substituent, if you combine, to come and have C2H5. Combine, this is also the same C2H5. So the substituents are called ethyl, and they're the same kind. Ethyl, and they're located on number 3 of the parent chain. So since there are 2 kinds, we would say 3 dimethyl. 3 for this and also 3 for that. Dimethyl. Longest chain is 6. Hexane. That's the name of the compound. So the arrow in number 3 here. We'll come back to number 3. This is not pentane, please, because the longest chain is 7. That's the arrow. The 7 is called heptane. Trimethyl heptane, please, corrected. This compound. First of all, we're going to identify. We see that we're seeing some groups here, methyl groups, chloro group. Then these are secondary substituents. Then we see a key or primary substituent, which is the double bond, the functional group. So we're going to identify the longest continuous chain, that is the parent chain. And that parent chain must contain the functional group. This is the group that defines the compound. And this group is predominant, or the predominance, that is, this group is, whatever I say, is considered first than these other groups in numbering. So to number, we have to start for the n that will give this functional group a smaller number before considering these other substituents. So let's find the longest carbon chain. 1, 2, 3, 4, 5. So it's 5 the longest carbon chain. Let's find out. 1, 2, 3, 4, 5. Whether you number it this way or the result gives you 5. Then let's find the branches. Branches. 1, 2, 3, 4, 5. Also 5 here. Again, 1, 2, 3, 4, 5. Also this side, 1, 2, 3, 4, 5. 5 3 times. Okay. Is there any other number more than, we'll consider these carbon atoms. Let's consider these ones here. So we now have 1, 2, 3, 4, 5, 6 Again, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. The longest carbon skeleton is 6. The longest chain is not 5. So that is 6. So now number that is, you can move it like this. You can take this one. That is the longest chain, 6. So the carbon atoms here, 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 and there will form 6 carbon. See that? You can say move down if you want. Then that is 6. Then we have to number the carbon atoms, either from this end A or this end B. But which side we consider? We consider the side that give us the smallest number to the functional group. This is the key group there. So this, it should be this side. 1, 2, 3. Why this will give you a bigger number? 1, 2, 3, 4, 5, which is larger. So start from the MB. 1, 2, 3, 4, 5, 6. Mind you, the carbon atoms and labeling are those ones that form the parent chain, the root name. That is 6. Having done that, we now name it. We can say chlorine, that is chloro, occurring 2 times. We can see this one, methyl. Look at this subsequent. Is there another methyl here, another methyl here? Because these ones are not marked as stereos, so they are not part of the parent chain. So now methyl is M, chlorine is C. So if we can order photos now in naming. So chlorine appears on number 2 carbon of the parent chain, number 3. We now say 2, 3, 2, 3, then hyphen dichloro. 2, 3, dichloro, 2 and 3. Then methyl lies on number 4. There are 2 methyl groups on number 4. There was another methyl group on number 5. When I say hyphen 4, 4, indicating the 2 methyl groups, number 4, 4, 4. Then this one is on number 5. Comma again, 5. Hyphen trimethyl, because there are 3 methyl groups. 4, 4, 5, trimethyl. Then the parent name, this compound has 6 carbon. Is not hexane, it's hexene called double bond. Trimethyl hexene, but the double bond, which number will you take? Take the smaller number, which is 2. When I say trimethyl has 2E. That's the name of the compound. 2, 3 hyphen dichloro hyphen 4, 4, 5 hyphen trimethyl has 2 in the names. The words are joined together. Numbers separated by comma, and the number and words separated by hyphen. You can still call it 2, 3 dichloro hyphen 4, 4, 5 trimethyl. Then hyphen again, 2 hyphen again, hexene. So I'll say here's 2 in, you can say 2 hexene. It is still right in the Aliphatic system of nomenclature. So you have to obey this rule. But any lapses here, you don't follow this. Even though the name will be correct, you don't put a hyphen. If you play hyphen with comma where it's supposed to be hyphen, or you put comma where you're supposed to have hyphen, you could fail it. So that is it. Then you go to number 2 example. Number 2 example, we have a compound there. Now, let's find the longest carbon chain. 1, 2, 3, 4. This is not carbon, remember this is chlorine. So this is giving us 1, 2, 3, 4. The thread chain is 4 here. Then let's look at the branches. 1, 2, 3, 4, 5. Move like this. 1, 2, 3, 4, 5. 5 is more than 4. Is that enough? Let's see count. Branch again. 1, 2, 3, 4, 5, 6. Repeat it. 1, 2, 3, 4, 5, 6. 6 is higher than 5. Another branch again. Another we can count. Let's see. 1, 2, 3, 4. No, smaller. 1, 2, 3, 4, 5, 6, the same thing as 1, 2, the same thing. The longest chain here is 6. So 6 carbon. Now you see that. 1, 2, there is one, mark it as 3, so you to number 1. The carbon atoms on the parent chain, longest continuous chain, that is 6. Now, having done that, we look at the substituent that are present. We are seeing chlorine here, that is chloro group. We see another group here, hydroxyl. So which of them will take, will have a better control of the compound. The one that defines the compound is this, hydroxyl. This is the primary substituent. That is the secondary substituent. So this is the functional group. And this compound is an alkanol derivative. So this is an alkanol. So this one, so in numbering the carbon atoms, we have to start on the end. That will give us the smallest number to the, we have to consider this position first before this. So this end gives us 1, 2, 3, 4, 5, 6. You see, if I start on this end, 1, 2, 3, 4, it's not proper because this group should take a smaller number, being the primary functional group than this. So to name the compound, this is now the prefix of the substituent. This chlorine is number 4. We now call it 4-chloro. 4-chloro. Then the compound is an alkanol. It has 6 carbon atoms. So 6 carbon atoms is hexanol. So we now say hexan hyphen. Position of the functional with the hydroxyl is number 2. Now say hexan-2-or. 4-chloro-hexan-2-or, because the 2 is the functional group, which is lower than the other secondary substituent, which is 4. Or we can say call it 4-chloro-2-hexanol is still correct. See the nomenclature, very perfect. So looking at number 3 example. Number 3 example, we have this compound. So this is find the longest chain, longest carbon chain here. Structure, the arrow identified here. We call it 4-chlorohexan-2-or. But let's go back to the structure, the arrow here. We have 1, 2, 3, 4, 5, 6 longest chain, yes. This is the substituent here. This is the primary group. This is the functional group. That why is hexan-2-or on number 2. This is number 4, which is 4-chloro. But there's a group that we left. That was an oversight. Look at the group here, methyl group. It's under substituent because this group is not numbered. So that's why it's an error in the naming. We're going to correct it now. So this is, of course, this group is the substituent because it's not part of the carbon atoms marked asterisk. This methyl group is not part of the 6 carbon atoms we have. So this is methyl number 4 and also chlorine number 4. Then how to separate them? Methyl is M, chlorine is C, starting letter. So separate them by order. We now say 4-chloro hyphen 4-methyl hexan-2-or. That's the right name. So this is wrong, please. So 4-chloro, because chlorine is number 4, and methyl is also on the same number 4. So you use an order to separate them. 4-chloro hyphen 4-methyl. Don't say 4-4-chloromethyl. They're not the same. You don't take the number first. The numbers will be taken first if the two groups are the same. Like chlorine appearing 2 times, you can say 4-4-dichloro. Or methyl 2 times, 4-4-dimethyl. But since they're different groups, you now say 4-chloro and 4-methyl. Don't use prefixes, you don't use di in this case. 4-chloro, 4-methyl, then hexan-2-or. So that's the correction here. To go to number 3 example. For number 3, we identify the longest chain. Number 3, the longest chain, let me write it up here for better arguing. So we have chlorine here, chlorine here. The longest carbon skeleton is, let's see, 1, 2, 3, 4, 5. 5 carbon atoms. There's no branch. These are chlorine. So 1, 2. So mark them as 3. 1, 2, 3, 4, 5. So we have substance. We have this group. We have this group, chloro. And remember, we have treated a homologous series. This is also another group, a key group called a functional group. So these are secondary substances. This is a primary substance with a functional group of alkanals or aldehydes. Alkanals. So name it, to number this compound, how to number the carbon atoms. We number from the carbon of the functional group, because that's the group that defines the compound. We now call this carbon number 1, not from this side. I have to give this one respect first. 1, 2, 3, 4, 5. So the compound is that there. 3, 4 dichloro. 3, 4. There are 2 or 10 can they use dichloro. Then there are 5 of them. 5 carbon atoms. Can't call it pentane, I call it pentanal. Alkanals end with Al. 3, 4 dichloro pentanal. So that is the name of the compound number 3. So having done that, go to number 4 up there. For number 4 example, look at the compound very well. Find the longest continuous carbon chain. If I look at this straight chain, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The branch chain. 1, 2, 3, 4. No, smaller. 1, 2, 3, smaller. 1, 2, 3, 4, 5, 6, 7. So you see that we're having 7. I repeat myself. 1, 2, 3, 4, 5, 6, 7 carbon. While the strength is 1, 2, 3, 4, 5, 6. So longest chain is giving us 7, bearing the functional group, the principal group. What the functional group there? The functional group there is the hydroxy group, which signifies alkanals, that's the principal or primary group. So to number, where we write a numbering. I have this end, let me call this end A, I have this end B to start numbering the carbon atoms. So which end am I going to prefer? The end that gives us the smallest number to the carbon of the functional group. So this end will be very far. 1, 2, 3, 4, 5, 6, 7. What this end gives us number 1 for this is the functional group. So consider this group first. Remember that apart from this functional group, we have another group. The group we have here, we have this group. We have this group are substituents. Substituents but are secondary. So the carbon atoms that are of importance here are the carbon atoms that are marking asterisks that form the parent chain. So number 1, number 2, number 3, 4, 5, 6, and then 7. So these other ones are now, since they are not marked asterisks, they are now substituents. So let's name the compound now. In the compound, the substituents are lying on number 5. 5, these are substituents. Let's call the substituent, that is, we say 5 dimethyl, because they are the same kind. 5 dimethyl. Then the functional group is on number 1 carbon, the lowest value. That is, and is 7 carbon, alkanol, heptanol. So this is now called 5 dimethyl heptan 1-or, showing the position of the functional group. So heptan 1-or I can still call it 5 dimethyl -1 heptanol. So when you see organic compound, before you number the substance, before you name it, out of the substances, we have different substances. Find out the one that identifies the compound, and that will be the functional group. And make sure when you're numbering the parent chain, the carbon atom but the functional group should take the smallest possible value as you have. So we'll go to number 5 example. This is number 5 example. Then write it down this side. CH3 bracket 2 C. As a beginner, you should try to open the structure to name it accordingly. So this bracket implies that the methyl group is not part of the thread chain. It means that 2 methyl groups are bonded to this carbon. That's CH3 and that's CH3. Then double bond, C, H, then CH3, then you can open it. You see, that's the full structure of the compound. And you're asked to name this compound. To name this compound, what do? We have to find the longest chain that bears the functional group. The functional group, you can see the double bond here is an alkene functional group. Longest chain, let's consider 1, 2, 3, 4. Straight chain being 4. Branch chain 1, 2, 3, 4. You see, okay? 1, 2, 3, 4. So I will not consider this 1, 2, 3 because this doesn't bear the functional group. So 1, 2, 3, 4. Or 1, 2, 3, 4. So longest chain 1, 2, 3, 4. You see, so since the branch chain and the straight chain are giving us equal number, we can now take the straight chain and the longest chain 4. Now, having done that, these are functional group. Question is this: we have the mark asterisk, the carbon atoms of the longest chain 1, 2, 3, 4. So mark asterisk. So number the carbon atoms. So which end do we start in numbering the carbon atoms? The end can give you a smaller number to the functional group. If I start for this end, I'm going to have 1, 2. How about this? I'm going to have 1, 2. So 2, also 2. So we do prefer any other end. But you remember, for the position, the functional group and the substituent that carry will be carrying the same number 2 and 2. So the only way we can number it perfectly is to start with this end 1, 2, so that the functional group will now be a lower number than the substituent, which is CH3. So the compound is now called 3-methyl. 4 carbon, 3-methyl, and then this butene, double bond, 3-methyl but. Which number do we choose? I'll try to choose this one, butene. Or you can call it 3-methyl hyphen 2-butene. That is it. So, having done that, go to number 6. Structure over here. Number 6 is a structure of a compound that has a double bond. To name this compound, we'll find the longest continuous chain. The longest chain of the continuous chain. We'll just carry the straight chain first. 1, 2, 3, 4, 5. The straight chain gives us 5 carbon. Let's get the branch chain. Branch chain 1, 2, 3, 4. Straight chain cannot be the longest chain because the straight chain does not carry the functional group. Remember, the functional group should be considered. So the straight chain is ruled off. Then let's move this like the 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And this happens to be the longest chain. 7. And it's bearing the functional group, the key group. So let's mark the carbon asterisk. Carbon 1, then mark them asterisk. The carbon of the root name. 7 of them asterisk. They will now look around the structure. Compound. And then we'll have the longest chain that have 7 carbon atoms. So to name it now, we'll look at the substituents. Chlorine is the substituent here. Then this is a substituent or secondary substituent. Then they have another one here. Look at this carbon. This carbon was not marked asterisk. So compressed ED equals the substituent. This one is nothing. This is nothing but CH3. So CH3 and then chlorine. So they are the 2 major substituents on the parent chain. Then to number, which end we start numbering? We have to consider the position of the functional group. First, 1, 2, 3, 4, 5. 4 and 5 from this end. 5 on this end, 1, 2, 3, 4. We prefer to this end, give us 1, 2, 3, 4. We continue, 5. See, that is 7 carbon. So 3 and 4 is preferred than going like this to get 4 and 5. So we have 3 and 4. To name this compound now, chlorine is number 4, methyl is number 4 also. But due to chemical order, chlorine comes first, C will come before M. The compound is now called 4-chloro. Chlorine is number 4. Then methyl, 4-methyl, also the same number 4. Then longest chain is 7. And it contains the double bond is an ene and kene, 7 carbon atoms. But then the double bond is between number 3 and number 4. So now we number from the end here. 1, 2, 3 for close proximity. 3 and 4. We choose 3 because 3 is smaller than 4. We now call it heptene. That is hept 3E or 4-chloro 4 hyphen 4 hyphen again, then hyphen again 3 hyphen heptene. So that's the full name of that compound. And on the board, we are asked to give the Aliphatic nomenclature of this compound. So that's the last example we're going to take for this video. Then the compound, as we said, let's find the hydrocarbon. If you look at it all around, you have only contains carbon and hydrogen. Number 2 point is an alkane, because it contains only single covalent bond between the carbon atoms. So, first of all, we'll find the longest continuous chain. And it's obvious that it's a straight chain, because straight chain gives us 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. That's the longest chain here. So the straight chain is the longest chain. 8. No other chain is more than that. 1, 2, 3, 4, 5, 6, 7, 8. The same 8. So we cannot say 1, 2, 3, that is small. 1, 2, 3, 4, 5. That is still small. That's 5. 1, 2, 3, 4, 5, 6, 7, 8. That is so. We take the straight chain and the longest chain because of 8. So having done that, then we have to number. What are the substituents here? Okay, let's mark asterisks as we used to do. Let's mark asterisks on the carbon atoms of the parent chain. That's the longest chain. Longest chain. Then mark it asterisk. So having done that, that means this one is going to be a substituent because it is not the carbon there, not marked asterisk. Then this group up also is going to be a substituent because the carbon atoms, the three carbon atoms, none is marked asterisk, so they don't belong to the parent chain. So then the compound, first of all, we're going to number from the end that is closer to the substituent. So we don't have any other principal functional group here. So we now have number 1, number 2 carbon, number 3, number 4, 5, 6, 7, 8. If I should start from this side, this substance will have a higher number, so this side is preferable. So having done that, to name, this group is called methyl group. Methyl. Then this group will add the carbon atoms. We have 3. The hydrogen is 3, 3, 6, then 7. This group looks like propyl group. Propyl, C3H7. But I won't call it propyl. I will call it propyl if it's in this form, CH2, CH2, CH3. That become propyl. But the branching, let's look at the 2 very well. This is propyl. Also the same C3H7, but here there is branching. It is now called this group. We call the branching, we call it isopropyl. Isopropyl. So the compound is now called M comes before I in English alphabet. Okay, no? I come before. Okay, we are not looking at the M, we're looking at the P. and M. So M comes before P. Hope I'm correct. M comes before P in this alphabet. So the next is now called 2-methyl, 2-methyl, under hyphen. This on number 3-isopropyl, 2-methyl. We are looking at the names methyl and propyl, please, not iso. Methyl and propyl. M should come first. So 2-methyl, 3-isopropyl. Then the parent chain has 8 carbon and it has single bonds. Octane. 2-methyl, 3-isopropyl, octane. So that's the name of this hydrocarbon. So we have come to the end of this tutorial. I hope you enjoyed the lecture. Try to, if you are not subscribed, subscribe by tapping on the subscription button. Share videos to your friends, to your classmates, wherever you are. Invite them to learn with us as we study chemistry or aspect of chemistry, physics, and further mathematics. Invite your friends, let them be aware of the channel, and always join us when we are studying, as we hope to improve in our videos. And then keep on watching always and stay connected. And as I said before, if you want to know organic compound, the first thing you have to know is to find out the homologous series where it belongs. We have done a video on homologous series. You can go back to it, to our videos, and then look at it. And then know the family where it belongs, identify the functional group, then identify the longest chain, the longest continuous chain. As I said, it must not be the straight chain. It can be a branch chain, longest continuous carbon chain, for which the compound will derive its name. So we call it the parent chain or the root name. When you identify that, then find the functional group, a group that identify the compound. Then number the parent chain, they come out of on the end, that give the least number to the carbon or the functional group. Then name subsequently. So thank you for watching. Remain connected.